Now, permit me to extend the very warmest of welcomes on this third lecture for applied health and data linkage. Now, a few of you have actually brought up lecture quality or audio quality issues specifically in the last lecture, and therefore in the light of this, I have made the extraordinary efforts to actually upload 2014 lectures, my lectures, for my own personal backup. However, I've thought through and reflected on how I can even give you better support, and today, basically before we start the lecture, I would like to actually consolidate and summarize the key points of what was covered in last week's lecture, so that the sound quality will not be compromised, and yet at the same time too, you get to see the slides as well as you get to see me. Now, jokes aside, so last week, let me summarize the lecture, beginning with an introduction to health information architecture. And the real-world example of the Department of Health Enterprise Information Model. Then we look at information engineering, which I will not summarize in that much detail, but I will focus on the important database design skills you will need for assignment 2, week 3, as well as assignment 2, week 9 and 11. And of course, last week we talked about logical data modeling from the top-down perspective, and we looked at entity relationship design or modeling, and I gave you a live demonstration on how it exactly looked like in the lecture itself. Right, so enterprise information architecture is the definition I emphasized on in the last lecture, and I trust that you've gone through the lecture and it's clear enough to you that it's an overall construct or framework of all the information in the organization at the strategic level, and the definition is essentially covers the concepts of principles, requirements, principles, models, what it is now, that means it is a living document or set of documents, and the directions and guidance necessary to act responsibly and evolve as the need of the marketplace or healthcare context changes. And of course, the definition, I emphasize the importance of actually going to Gartner to take a look at this definition. So, health information exchange basically enables, in a very big continent like America, this health information exchange enables different healthcare organizations with different systems of different sizes and complexities to come together and share information for the purpose of communication as well as sharing of resources and knowledge. So, I emphasize on the importance of modeling. So what's a model? A model is defined as something that you build, a construct to represent a problem or a situation or a scenario or problem in reality. And it can be a physical model, it could be an engineering physical model or an architecture model that you see so many of them in this building, or it could be an electronic model. It could be an electronically generated engineering model on, let's say, AutoCAD and so on. And the purpose of modeling is to build something so that you understand what you're studying. At the same time too, if it's a challenge or problem that needs to be overcome, what are the solution options to actually overcome that problem? So that's basically what a model is for. And your database design, top-down database design, is a modeling approach to how a database is designed and constructed. So we shall look at definitions of database very shortly. But we have different types of models at the enterprise level, beginning from the top or high-level strategic process models, all the way down to the individual operational processes or business processes at the customer-facing or patient-facing front end. We also have the data model that defines all the data required to support organizational processes. And I emphasized in my first lecture that database, and the second lecture as well, database is at the heart of a healthcare organization, or for that matter, any organization's needs. So, last week, the lecture is really conducted, so what I will do is basically just run through in summary all the remaining slides. So basically this defines the healthcare context of all of West Australia, beginning from the national level, at federal level, all the way to the individual government and controlling information, health information bodies, down to the individual healthcare organizations in all their varieties. And at the end of it, the bottom of it, the foundation of all that will be your well-designed databases to support all healthcare operation, transaction processing needs, as well as management decision at all levels. Supervisory or customer patient-facing level, down up to middle management, right up to the very highest levels, and that will be the strategic level. Then we looked at the various ways in which enterprise information architectures are defined and applied. And the purpose of an enterprise information architecture really is to ensure that your database designs and data models used in the individual healthcare organizations under their charge are consistent. This is to ensure that all data at individual databases level within the respective healthcare organizations are consistent and follow standards. So that essentially is a very well designed healthcare enterprise information architecture model. So the two main enterprise entities, if you like, that represent healthcare organizations throughout Western Australia will begin with contact episode. Now, why is contact episode so important? This is because it is a transaction, an event that is recorded that defines the first point of interaction, the first point of contact between a patient and its respective healthcare organization, be it a physiotherapist clinic for an appointment or even an accident and emergency admission after a serious injury or fight in Northbridge on Saturday evening. So whatever it is, that is the first point of contact. And then we have the master enterprise entity called event, of which we have different types of events. Broadly, we have service events that also involve not just healthcare service events in detail here, but also other types of service events. Now, given the constraints of this third lecture, and I have to cover the lecture 3 content as well, I will be moving along in a consolidation and more of a summary at a high level. So this basically defines the various levels of the enterprise information model itself. So we have the business area model that defines both the process as well as the business area data model. And then we have the individual systems, where we have the application level logical data model that is ultimately translated into a physical database design. So if it is a Microsoft Access that you are building as a health information manager on your own, within your office, yes, the physical database model will be the Microsoft Access database design that you see in the relationships window that you followed in your assignment 2 week 3 when you imported that first 3 starter spreadsheets into your newly created A2 week 3 Access assignment, and just for that you will get a full 2 marks. Now, as you import into the database itself, the starter spreadsheets, a very important consideration is to make sure that the primary keys that you design for the import, defined for the import as part of the import steps, are following exactly according to the relationships window screenshot in the A2 W3 expected results document. You have to follow exactly, otherwise you might create a mess in your database and you have a lot of things to tidy up. So some of you may have encountered that situation. What I would recommend is do a fresh start, re-import everything rather than try to fix it. You will save a lot more time. Okay, in short, do it right the first time, all the time. Now, so that's information engineering, a definition. Essentially, it is a strategic level application of interlocking set of formal enterprise modeling techniques for the planning, analysis, design, and implementation, construction of effective information systems across an enterprise-wide basis or a major area of the enterprise if it happens to be very large. So we look at the 4 levels of the information pyramid. information engineering pyramid. Strategy that results in the enterprise information model, then the business area analysis that results in the logical data models for the respective organizational or business areas, and of course the technical design or logical design that defines the database design and process designs, the construction and the programming and the implementation. So these are all the functions, what it is for. And I would suggest that in this consolidation and summary, you read through what I've just explained. So, in business area analysis, one of the principal activities would be that of database design. And the quality of design will impact significantly your use of that health information system built on that database. Now, very, very important, most important diagram that will set the stage for your future success and career. Always remember, whatever information system that you build will always rest on a well-designed database. So this is the master diagram, if you like, okay, for your one of the master diagrams, if not the master diagram for your entire unit and your future career. Always remember, never forget that. So, having discussed that an effective information system rests on a well-designed database, we need to understand that an information system, a health information system in your context, represents the operating context in which your databases are run. So therefore, we need to understand what an information system is, or a system for short. Now, a system is defined as an integrated collection of interrelated elements or components. These components include the database, the software functions that access and update the database, the query functions you create in assignment 2 week 3 to retrieve information for decision making and healthcare reporting in your database. So that's the practical value of what you're learning. These skills are very, very applicable to your future career as health information managers. One of our current students and many of our previous students now use Access regularly to construct queries and so on. So it's most important that you have a good database design on which you can build your queries. Otherwise, how can you have confidence unless you have a well-designed database upon which your effective information system rests? So, what is a database then? A database is defined as a living electronic representation of organizational reality. Each aspect or dimension of that reality is captured in the form of distinct entities of interest, be they patient, be they doctor, be they treatment plan, be they medication or drug, whatever it is, anything that needs to be tracked, updated, transactions processed against it would be part of that database. And that database doesn't have these entities or database tables. Now I will use the term table and entity interchangeably. They mean one and the same thing. Now these entities are not isolated in themselves because in any organization they work together. They are interrelated, interconnected. So they are connected by relationships called business rules that enable their tracking, update and integrity controls applied to ensure data quality, ensure data integrity in your well-designed database. Something I emphasized very much in my first lecture. So each entity is an electronic representation of its real-world equivalent by a logical grouping of data elements called attributes. Attributes basically, the word attribute means characteristics.